An everyday sight we often take for granted, bridges are engineering marvels designed to withstand time, the weather, and the weight of thousands of vehicles passing over them every day. But what happens when this trust is broken, when a key piece of infrastructure relied upon by thousands every day falls out from under our feet without warning? The 14th of August 2018, Genoa, Italy. Completed in 1967, the Ponte Morandi Bridge has stood as a vital link between the eastern and western parts of Genoa for nearly 50 years, carrying the A10 motorway, one of Italy's busiest roads. But beneath its imposing concrete and steel structure, problems are brewing. Engineers have expressed concerns about the bridge's condition for years. Reports of structural deterioration, corrosion in the cables, and visible cracking has raised alarms. But despite the maintenance efforts, the problems would persist. On the morning of the 14th of August, Genoa is experiencing heavy rainfall, the roads are slick, visibility is low, and traffic is steady as vehicles make their way across in the poor conditions. Designed by the Italian engineer Riccardo Morandi, construction began in 1963 and was completed in 1967. The Ponte Morandi Bridge is a cable-stayed bridge characterised by a pre-stressed concrete structure for the piers, pylons and deck, very few stays, as few as 2 per span, and a hybrid system for them constructed from steel cables encased in pre-stressed concrete. Pre-stressed concrete is a type of concrete that has been preloaded with internal stress to improve its strength and performance under tension. This pre-stressing is done by stretching steel cables inside a mould before the concrete is poured into it, encasing the cables inside. As the concrete hardens, the tension is released, and the cables try to return to their original length, compressing the concrete in the process. This helps the concrete resist tensile forces that would normally cause cracking. The advantages are that it can handle more load compared to regular concrete, and the internal compression prevents cracks from forming. When used in bridge construction, beams can be longer with fewer supports. It is also more resilient to weather, corrosion, and heavy use. The bridge stretches around 3/4 of a mile across the Polsevera River and is a key part of the A10 motorway, connecting Genoa to France. At the time, its design was unconventional but seen as an innovative approach. At 11:36 am, in the downpour with 50 years of non-stop traffic passing over it and weather corrosion, the bridge creaks and strains under its own weight. Unbeknownst to the everyday individuals travelling over it, a 210-metre section suddenly gives way. Vehicles, some carrying entire families, others delivery drivers and those on holiday, plummet 45 metres to the ground below. Those nearby hear a deafening roar as concrete and steel shatter upon impact. Rescue workers rush to the disaster zone, digging through the wreckage in search of survivors. Cars and other vehicles have fallen and been crushed under the debris. Buildings beneath the bridge are completely destroyed. It is a scene of utter devastation. 43 people lose their lives, while dozens more are injured. Miraculously, some in their vehicles actually survive the fall thanks to the shared impact force of the bridge falling with them, producing a cushioning effect. One of the most iconic visuals of the collapse is a solitary supermarket delivery lorry whose driver managed to stop mere meters before falling into the void. The Italian government launched a full-scale investigation to uncover what could cause the bridge to fail so suddenly. The findings point to a mix of factors: insufficient maintenance, aging materials, and biggest of all, a fundamental flaw in the bridge's design. The bridge required constant repairs starting in the 1970s due to a miscalculation of how the concrete would settle over time. This caused the roadway to shift unevenly, making it unstable. After years of adjustments and structural work, the deck was finally considered level by the mid-1980s. In 1979, the bridge's designer Riccardo Morandi warned that the structure would eventually need major repairs, including rust removal and reinforcement with protective materials. By the 1990s, Pillar 11 showed significant damage, with about a third of its steel tendons corroded. These tendons, originally designed to support far more weight, had weakened over time. Only Pillar 11 had been inspected internally, revealing broken and rusted strands. As a temporary fix, external steel cables were added to reinforce Pillar 11, while Pillar 10 received steel sheathing at the top. Concerns about the bridge's safety had been raised for years. In 2016, government officials were repeatedly informed about the need for urgent maintenance. A 2017 report from a university in Genoa highlighted serious structural weaknesses in Pillar 9, which eventually collapsed. By early 2018, tests showed a noticeable reduction in the strength of the bridge's supports. A visible crack appeared near Pillar 9 at least 2 weeks before the collapse, possibly signalling that one of its cables had stretched. Despite these warnings, no action was taken to limit traffic or reduce weight on the bridge. In May 2018, a contract was announced for a major structural upgrade, with work planned over the next 5 years. However, just months later, the bridge would collapse. Unlike steel cables, which can be easily inspected and replaced, Morandi's use of concrete-encased cables made it difficult to assess their condition. Over the years, wear and tear, exposure to the elements, and heavy traffic took their toll. Maintenance work was carried out, but experts warned that the bridge might not last much longer without major renovations. The concrete-encased cables had severely weakened over time, and previous repair efforts had not been enough to prevent disaster. It was suggested at one point to add additional support cables. This would have been the simplest fix, but it was thought this would ruin the bridge's aesthetic. After a controlled demolition, the Ponte Morandi bridge would be replaced with a new one, the Genoa San Giorgio Bridge, which was completed in 2020. Unlike its predecessor, it was built using modern construction and designed for long-term durability. This new bridge stands as a testament to resilience and engineering progress, but the memory of the Ponte Morandi bridge collapse remains a harsh reminder of the importance of proper design and rigorous maintenance and safety standards. The collapse was one of the worst infrastructure disasters in modern European history, but raised worldwide awareness about the dangers of aging infrastructure and the need for continuous inspection and maintenance. Could similar disasters be lurking elsewhere waiting to happen? Only time will tell. If you enjoyed this YouTube documentary, give it a like for the time and effort it took me to make, and subscribe to the channel if you want to catch new episodes as I upload them. You can also check out some of my existing videos. Thank you for watching, and I'll see you next time.